If you look at the question here, number 5, it gives you a list of the births, deaths, immigration, and emigration for a population of California quail. And it gives you this over 4 years, and it states that the total population size is 1,000 individuals. So what we're asked to do here is calculate the growth rates for these. So in order to do that, I'm going to use this population growth rate equation right here, and you'll see the work for that now. So you can see that I've added to calculate the growth rate, which is represented as R. We're going to take the births plus the deaths, and then we're going to subtract the deaths and emigration totals from that and divide by the total population, okay? And that's going to give you a value of 0.001 for year 1. And so if we're representing this in the way that we would plug it into the exponential growth equation, this is the number we would use. However, it can also be presented as a percentage just by moving the decimal 2 places to the right or multiplying it by 100, and that'll give you the value as a percentage. One thing that I did here is I want you to notice that from year to year, I added the population growth to the number of individuals. So we gained 1 individual in the first year, so my denominator in year 2 is going to incorporate that. I gained 6 individuals in year 2, so I incorporate that, and I kept adding to the population. The next thing we're going to look at is doubling time, and there's a rule of 70, okay? And in order to calculate the doubling time for a given population, you just take the number 70, which is rounded. It really should be 69.3, and you divide that by the growth rate, and that'll tell you the amount of time it takes for a given population to double. So in this example right here, if it tells you that the global growth rate is 1.2%, to figure out how long it would take for the population to double, you would just take 70 and divide that by 1.2, and you would find that based on our current growth rate, it would take 58.3 years for our population to double. Let's hope that that doesn't happen, or we will far exceed our carrying capacity. So here we have a couple more practice problems involving this, and we're going to take a look at it from 2 angles. So if California, it will double its population size in how many years with a present growth rate of 1.5%? And then in the next problem, it tells you the population is doubling every 15 years and asks you to calculate the growth rate. So if you can try those right now. And you'll see that to answer the first question, to calculate the doubling time, you just divide 70 by that growth rate, and you'd find that it would take 47 years for California to double its population. And in the next problem, to calculate the growth rate, you can rearrange it algebraically so that you're dividing 70 by the doubling time, and that would equal the growth rate, which we would find to be 4.7%. The next thing we're going to look at is the exponential growth model, and that is going to be represented with this equation right here, where n represents the number of individuals at a given time of interest, n sub 0 tells you the initial population amount, and then you're going to multiply that by e raised to the rate times the time. So the rate we're going to use is the rate we were talking about, the population growth rate, not represented as a percentage, but represented as a decimal, and we're going to also look at the time. All right, so the practice problem we have here is a population of scrub jays is growing at a rate of 2% per year. What will the population of the scrub jay be in the year 2050 and 2075? And it tells you that the population is 9,000 individuals, and the year this problem was made was 2009, a long, long time ago. And then, so when you do the calculation, in 2050, which would be 41 years from the time this worksheet was generated, you would simply plug in 9,000 as your initial population amount, 0.02 as the growth rate, and 41 years. So we would multiply 9,000 times e raised to the 0.02 times 41, and we'd find that there would be 20,400 scrub jays in 2050. Assuming the same growth rate by 2075, plugging in the same equation, you could see that there would be 33,700 scrub jays. So we've looked at a bunch of different ways to do calculations with population numbers, and hopefully you find this helpful.